hammerFall gravity-powered electric generator. Nice shot of the morning moon. This is probably a little after dawn, so I'm finding it extremely difficult to precisely set the cogs, and as a result, sometimes two weights are falling, and on the other end, actually it creates a condition where three weights are falling, which is kind of cool. And so that's producing a result of between 36 and 50 volts at the output. So it pulses up and down, and what we're going to try to do is install a larger flywheel. It seems like the easiest way to get more weights falling at the same time is to increase the speed at the cog location, and I'm not sure if it'll work, but we will. Well, yeah, it will work, but I'm not sure if after the modification, if there'll be enough torque to actually still power the device. This currently is a 6-to-1, and if we change it to a 5-to-1, we'll get a higher speed, and that'll help. If it does still have enough torque, that'll create a higher RPM at the output, which will ultimately improve the overall test results. You start self-doubting yourself, and I was thinking about conservation of energy, and I don't know if it really applies. Maybe it does. Comments are welcome. But if there's 30 watts here, it produces, you're lifting weights on the other end. And, so at a perfect system, it would only produce, I don't know, maybe I'm wrong, 30 watts, as the weights fall. So, and if that's the case, there's no way we're going to be able to generate more than 30 watts at the output. So comments are welcome on that thought. The other side of the coin is there are two different systems, and you're accumulating a higher potential at the input of the second machine. See, I can I can talk myself in circles here, but we'll keep the test results as honest and conservative numbers as possible, and we'll post results when available. Just want to document the performance of the rack and pinion to make sure none of the one-way bearings are slipping. Earlier I found that two of them had broken free from the hub. I used super glue to secure them in the aluminum hub, and when I was using them for testing on other devices, they were over torqued and ripped loose. So that's a problem area. It'll have to be resolved. So anyways, yeah, there we go. So I guess it's documented. Anyways, I'm gonna go back and take a nap. Hope everybody has a great day. Enjoy the day. Cheers. Yeah, larger flywheel. Anybody has suggestions upon, large? I understand the basics, like larger diameter, weights around the outside, but there must be some sort of limit as to the, the weight of the flywheel. I'm thinking, to get it moving, it's going to consume a lot, energy. So the heavier it is, the more energy it's going to consume. just to get it moving. And then, but once it's moving, you know, is it still consuming all that energy or not? But I really don't know. So if anybody has suggestions on how to properly size a flywheel, please let me know. I received information about a text called, what is it, Mark's, I don't know, I think it's mechanical engineering textbook, and I ordered that, so maybe that'll have the information in it. I really don't know. But, suggestions welcome. Hope everybody has a great day. Cheers. Again, that's between 50 and about 35. So you know, we add a flywheel and it'll smooth it out and make it more constant at the output. Hope everybody has a great day. Cheers. Oh yeah, at startup it creates a condition where there's 4 weights falling at one time, and so as that you know, occurs, you know, you get a much higher RPM, and it'll you know, zip right up to 80 volts, and then it goes back to the 30-50 configuration. So we that's documented as well. So the next step will be tested under a resistive load. I'll post results when available. Enjoy the day. Cheers.